Have you noticed that Howard can take any topic and use it to remind you that he went to space?
Interesting hypothesis. Let's apply the scientific method. Perform an experiment.
Okay. Hey, Howard, any thoughts on where we should get dinner?
Anywhere but the space station. I mean, on a good day, dinner was a bag full of meatloaf. But hey, you don't go there for the food, you go there for the view.
It's fascinating. Let me see if I can duplicate the result. Howard, I've always thought the lemon was an underrated fruit. Care to weigh in?
Not really.
Oh, well.
You know, people say the Soyuz capsule is a lemon, but... Yeah, but hey, that baby got me to space and back.
Thanks, Leonard and Sheldon. I think that makes a good introduction for our discussion about the scientific method. We're going to review the steps of the scientific method. We're going to update your definition of a hypothesis and then talk about the difference between a theory and a law. If you have any questions about these steps, write it down so you can ask me about it next class. Otherwise, be prepared to discuss these in detail next time you're in class. Most of you, if I asked you about hypothesis, you would say educated guess. And this is fine, but we want to add a step to that. We want to make sure that we concentrate on the idea that our hypothesis has got to be testable. Right? If it's not testable, then science can't address that problem right now. Right? Usually it's going to be in an if-then statement, putting the independent variable in the if clause and the dependent variable in the then clause. So now you're thinking, what if I don't want to go into science? Why do I have to learn this? The idea behind the scientific method is it's a way to solve problems. People use it in all kinds of careers. And our goal here in chemistry really is critical thinking. So check out this clip from the TV show Elementary.
I take it you two have worked together before?
Yeah, 10 years ago, I was assigned to Scotland Yard. Holmes worked homicide.
You said there were also signs of a struggle in the master bedroom. Just in the safe room.
What safe room?
One behind that wall. The extra weight of a safe room's steel reinforcements can cause the floor around it to decline slightly, creating a slope between 1 and 5 degrees. Sometimes I hate it when I'm right.
Be ready to explain to me how Sherlock Holmes applied the scientific method in this example. Let's talk about theories a little bit. The problem with the word theory is in everyday talk out on the street, theory is like a guess. In science, it's not at all like a guess. It's well supported, documented, lots of evidence, lots of data, all saying that the theory is the best explanation for what's happening. Now, as a scientist, we have to be a skeptic, always looking for the weak spot in the theory, always looking for new evidence, applying new technology, and this is how theories change. But when someone presents a theory, one, you need to think about it as being the strongest explanation at this point in time, and then two, looking for weaknesses, looking for places where it could either be proven stronger or disproven. Let's look at the Big Bang Theory that you learned about in earth science. It's the most widely accepted model for the scientific origin of the universe because it has the most evidence that supports it and the least amount of evidence that refutes it. That evidence includes things like the fact that the universe is constantly expanding, the existence of cosmic microwave background radiation, which the Big Bang predicts the first atoms to have formed about 300,000 years after the Big Bang, and that matches. Also, if you look at the elements in the universe, the amount of different elements, the amount of hydrogen, the amount of helium, that matches what the Big Bang would predict. The actual amounts in the universe match the prediction. So we've got lots of things that support the Big Bang. Will the Big Bang change over time? Absolutely. As technology gets better, more details will be added to the Big Bang. Some things might be shifted a little bit. It might be turned completely upside down. We don't know. But right now, with the evidence we have right now, the Big Bang is it. It is the best explanation for the formation of our universe. And finally, how's the law different than a theory? All a law does is summarize results of lots of observations and experiments. It never explains why. Theories explain why. Laws tell you what's going to happen.